So we have all seen these signs as we drive around town or go to the grocery store. We see that, well, the price of a gallon of gas or diesel fuel is, in this case, $2.96 per gallon. Diesel fuel, $3.09 per gallon. We also see going to the store, we can buy some, it's a 1 pound of sugar for $1.68 for that pound, or we can buy it for 10.5 cents per ounce. What you're seeing here are things called ratios. And a ratio is defined as a comparison of two numbers. So when we're talking about the cost per gallon of gas, we have a cost, which is a number, and per 1 gallon, which is also a number. And ratios can take different forms. Again, we're comparing two numbers, so here are the forms that we can take. We can take a ratio as this. It could be 4, and we can use the word 2, 5, 4 to 5. We can also use a colon, 4 colon 5. And we can also write it as a fraction. A ratio can be 4 over 5. And when we write ratios, we always leave them improper as well. We're not going to use mixed numbers like fractions along the way either. So speaking of ratios, which you've already got the definition up in the vocab part of your notes, let's go down to this first problem in the notes section. A group of people was surveyed as to what sport each person preferred to participate in. And the results are there. And so let's write a ratio. Let's say we want the ratio, for example, of the people that chose tennis to the people that chose golf. So what we would do is we would find the people that chose tennis, which is 27, and the people that chose golf, which is 14, and we can write that in one of the three ways. We can write as a fraction, 27 to 14, with a colon, or with the word 2. All three of those are appropriate ways to write a ratio. And the order does matter. If we did 14 over 27, well, that'd be golf to tennis instead. Okay, so now that we know that a ratio is a comparison of two numbers, there's a specific kind of ratio that we can look at called a unit rate. And it's what we do see when we drive around town and see the cost per 1 gallon of gas. And so a unit rate is a comparison showing how many units of the first quantity correspond to 1 unit of the second quantity. So we're looking for, well, how much does it cost per 1 ounce, or per 1 pound, or per 1 gallon? Okay, so that's a unit rate. So now that we've got that definition filled in the vocab part, let's go down to the second example in your notes here. So cheddar cheese costs $1.88 for 8 ounces at store A, and the same cheese costs $2.40 for 12 ounces at store B. We want to find the unit rate for each store, so let's do that for store A. So what we're trying to do is we're trying to find the cost per ounce. Now the way I said that is how we're going to divide. So we're going to take the cost per ounce. $1.88 divided by 8. Well, if we divide that, what that does is it reduces to 0.235 over 1. Now, guys, here's what that really means. It means that at store A, the cost is 0.235 cents per ounce. That's 23.5 cents if we wanted to be a little bit more specific in terms of the money there. So let's do store B. So store B, same situation, but for store B, their cost per ounce is $2.40 divided by 12, which figures out to be 0.20 over 1. Well, if we interpret that in terms of money, that's 20 cents per ounce. So which store has the better buy? Well, it's B, because 20 cents per ounce is less than 23.5 cents per ounce. And so that's a little bit about unit rates and how they can be used to compare when going to the store. So it's good to know, save you some money along the way. So now putting these things together in what's called a proportion. So in your vocabulary, a proportion is a comparison of two ratios. And this is what a proportion looks like. A over B is equal to C over D. That's a proportion. There's a couple different ways in which you can solve a proportion, and here's the first. In this example, solve 5/6 equals x over 30. So we've got two ratios that are equal to each other, and we want to find the value of x. So if we treat this like fractions, one thing that we can do is we can go, okay, well, 6 times 5, back up, 6 times 5 gives me 30. So if whatever I do to the bottom, I can do to the top. So 5 times 5 means x is going to be equal to 25. And I'm done. Now, that worked pretty good. But a lot of proportions, well, don't have that characteristic like we just saw. So if we go over to the right and solve x over 7 is equal to 3 over 8, well, 7 times what is 8? Well, that's not very nice. So here's what we can do. We're going to cross multiply. We're going to take this 8 and the x, and we're going to multiply. And that's going to give us 8x. And then what we're going to do is we're going to multiply 7 and 3. That's going to give us 21. So right there, we change this from two ratios into an equation with, well, an x on one side, a number on the other side. So now we just have to, well, solve for x. And so to do so, I'll divide both sides by 8, and x is equal to 21 over 8. A little hard to check, but again, now we're starting to see how solving equations is really, really important, because we can use them in other contexts as well. So let's use that principle along the way with this second one. So this next item, we're going to cross multiply. Now we're going to have to use the distributive property. So we're going to multiply first 6 times x plus 1. And it doesn't matter if that goes on the left side or the right side. And then we're going to come along and take 4 times 2x minus 5. All right, we're ready to roll. So if we distribute on the left side, taking the 6 through, it's going to give us 6x plus 6. And taking the 4 through the right side, that's going to give us 8x minus 20. Now I've got to make a decision. I've got to get, well, x by itself. And so I'm going to move the 6x to the other side. That's going to keep my x term positive. So I'm going to be left with 6 is equal to 2x minus 20. Alright, I'm going to run out of room here, so I'm going to add 20 to both sides to get the x term by itself. I'm going to go up top here, if you don't mind. And that's going to give me 26 is equal to 2x, and so dividing both sides by 2 gives me 13 is equal to x, or x is equal to 13. And we just solved a proportion using our tremendous algebra skills involving the distributive property. And so the last thing, why do we do ratios, unit rates, and proportions? Well, we do it with a lot of geometry, but we do it to make some comparisons and make some decisions, much like our last item here. Your car gets 28 miles per gallon. And so let's write that as a ratio. 28 miles per 1 gallon. Now, if we travel 350 miles, how many gallons of fuel will be used? Well, 28 gallons, or 28 miles, excuse me, we're going to have to put 350 on the top of the other ratio. Because on the top is all the miles, and on the bottom is all the gallons. So we don't know how many gallons we need to go 350 miles. So Let's cross multiply. Gives us 28x on one side. And then on the other side, it's going to give us, well, just 350. So dividing both sides by 28 is going to tell us how many gallons we need, which is 12.5. It's always good to label with stuff, and so this is no exception. 12.5 gallons of gas will get us that 350 miles that we need to travel. So that's the beginning of ratios, unit rates, and proportions.